workforce development and manufacturing innovations to enhance the chemical process industry briefing. We're part of ASCG, the American Institute of Chemical Engineers, and together with the House Manufacturing Caucus. Thank you for hosting us. So if you want to say a few words on how to arrive to that.
So thanks. My name is Kevin Jurens, and I'm an ASB fellow working in the office of Congressman Tim Ryan. And so Congressman Ryan co-chairs the House Manufacturing Caucus with Tom Reed, who's represented by Casey Morris, who's also here. So we chair the caucus, and so on behalf of the Manufacturing Caucus, I want to welcome you for coming, and thank you for coming to our briefing today. I want to thank the American Institute of Chemical Engineers for hosting the event. I want to thank the Rapid Manufacturing Institute for sharing your experience and knowledge with us. And I very much look forward to hearing the discussions today. And most importantly, I want to thank our panel members for coming to share your information. So today's briefing focuses on two topics that are quite important to Congressman Ryan. He's very passionate about advancements for U.S. manufacturing, which is our main topic here, as well as continued training and development of our workforce. So very important topics. And so we're fortunate today to hear from one of the 14 Manufacturing USA institutes. So these institutes are quite important. They're spread across the country. They are public-private partnerships that have attracted more than $400 million in state investments and more than $1.5 billion in industry cost share. So these are quite successful. Relevant to our briefing today, the Manufacturing USA Institutes in FY18 conducted workforce development efforts that involve more than 200,000 workers, students, and educators. So that's something I think we're going to focus on also today. So anyway, I look forward to the briefing, and thank you all for coming.
Thank you for hosting us again. My name is Ignacio Palau Rivera. I'm the Technology Platform Director for the Rapid Manufacturing Institute. I want to introduce a little bit what Rapid is. As you just heard, Rapid is one of the 14 manufacturing institutes. Specifically, Rapid is a public-private partnership between the American Institute of Chemical Engineers and the Advanced Manufacturing Office of the Department of Energy. Our specific topics that we address is modular chemical process intensification, what we call CPI, which is really the merging of two separate or different concepts. Process intensification, which is kind of a rethinking of chemical processes from the fundamental phenomena of those processes instead of the pre-made unit operations thinking that has been the traditional way to look at it. The second one is modularization, so going to modular, smaller processes, distributed processes, getting to larger processing by numbering up instead of scaling up a single process unit, or single process, I should say. This distributed nature allows for lower energy and water use, lower resources, higher capital efficiency, so lower capital investment, lower waste, lower emissions, and increased yield and sustainability. Rapid, as all the other institutes, is a membership organization. We have about 77, 78 members. It changes by the week, something on that order. About 33, 35 on the order of that are companies, industrial companies, both large and small. 30-some of the members are universities, some of the highest ranked R&D and universities in our area in chemical engineering are part of our membership, and the rest are national labs and other research institutions. As far as our budget, right now, we're looking for the 5 years of the initial agreement, roughly at $150 million, which is more than doubling the federal investment of $70 million. In the briefing today, we're looking to touch on 5 specific topics. The first one is Rapid's role in transforming the chemical industry, the process industries. Looking at these issues of distributed manufacturing, how it affects jobs, rural development, lots of topics there. The second one is how AHCHE and other nonprofit organizations can act as conveners of communities to address and build these communities to address a lot of these issues. Third one is how the current chemical engineering and other engineering and technical training do not really sufficiently address the needs of future generations. The fourth topic is an introduction, a little deeper introduction to what we are doing within RAPID, not just on the R&D development, but also in our education and workforce development efforts. Especially talking on an internship program, which has been very successful, or is being very successful, I should say. And the fifth topic is presenting one of the ideas on how to improve learning through these, what we call skills-based learning, which is in partnership between academia and industry, and using us or other similar organizations as brokers. I want to introduce the five speakers, and then we'll, in roughly the order that they're going to speak. To my left, Bob Calloway, Associate Lab Director at Savannah River National Lab, and also member of the RAPID Governing Board. Then we have Ashley Smith-Schachter to my right. She's the Director of Education and Workforce Development for the RAPID Manufacturing Institute. Next to her, Monty Alger, Professor of Chemical Engineering at Penn State University, after a very successful industrial career, and also President-elect of AHCHE. Hannah Mernon, next to Dawn. She's the CTO of Comfort Management Systems in Delaware, one of the RAPID members, and also member of the governing board of the RAPID Institute. And next we have Dan Wazinski, a tech fellow at Dow in manufacturing engineering. And Dow is also a member of RAPID, I would say one of the higher ranking members on the industrial side for large companies. So we're going to start hearing from Ron, our first speaker. And a couple slides.
Well, thank you. I'm going to give you a little bit of history on why both our lab became interested in this, a little bit about how the chemical industry got interested. Well, back in the late 80s, early 90s, people said, hey, chemical plants are unsafe, too much material at risk. You know, anybody that's ever seen a very large chemical factory, huge tanks, a lot of material there, and it was at risk. So the people started investigating how to make things smaller. But if you dial forward into this century, as these slides show, both on the defense side of the Department of Energy, as well as in the chemical process industry, we were having trouble building large chemical plants. A lot of them became one of a kind. Not that they had never been done before, they had been done in the 40s, but our workforce hadn't done it, right? You know, it's a couple generations since we built very large, chemical factories. Remember in the 90s, essentially, gasoline's high, we're starting to lose manufacturing, it's going overseas, we're losing our workforce that can do this. And that's why we're here today. That's why we funded all this manufacturing in the USA. So both, at the lab, we realized there's got to be a better way than just making a large nuclear chemical plant. Or there's got to be a way that's better than just making a large, refinery or the large chemical plant. So we had both an innovation problem and we had a culture change that we need to go through. Same time, we're impacted, as that bar graph showed you, we have our workforce retired, right? They're all people, hey, I built something maybe in my past, but the next generation hasn't. So we realized at the lab we had to change our thinking. We had to change our culture through education. So we had to do it the hard way. Of course, this manufacturing institute wasn't really started up yet, but it got started with a lot of interest from Dow Chemical, Combat Membrane Systems, and other companies, and a proposal was put together. more importantly, from a national defense perspective, we were able to see changes from a culture change, right? This graphic here to the left is a mobile plutonium factory. That factory is designed to be deployed anywhere in the world, right? That's the first generation. There were 9 sea-land containers. The next generation, which we just broke ground on, we completed, it's 1/3 smaller. So 60% smaller, just by training our workforce to think differently, right? As well as innovate. So that came through a series of trainings. It also came through some of the educational platforms that the manufacturing institutes gave us. We could not have kept this going, because we're like anybody else. We change my lab director changes, my president of my company changes, just like Congress changes every 2 years. So to keep things going, you need an institute that stands the test of time, that can be the knowledge warehouse. Over on that far right is a mobile factory that's designed to basically clean up nuclear waste. It sits on a tank. It was deployed. With the research funding that Rapid provided, we took that mobile factory and made it go 10x faster. Now that technology hasn't been deployed yet, but we would not have funded that internally, because that works pretty well. And to get to that next level and to make costs even cheaper, sometimes the factories don't want to change, right? So you need these institutes to basically affect that innovation change and bring it to the marketplace. Now I've got a picture of a drone up there. That is a drone that operates on solid fuel, and it goes 3 times longer than an electric battery. So imagine if you're on the other side of the DC Beltway and you want to fly a drone to the White House. Not a good thing, but from a national security perspective, if you can do that and you're a warfighter, you can be 3 times farther away. That's done through microheat exchange technology that was innovated by Oregon State University. It's all a solid state hydrogen fuel with a fuel cell. It's the same weight as the battery drone. Now I show a picture of a submarine here because I can't show you the tritium process that runs all our nuclear weapons throughout the complex. But we've taken technology developed in that ion exchange program and learned how to separate tritium faster. So the chemical industry and DOE and our National Defense Commission are very much aligned. I mean, you can talk about any part that goes in a tank, it's probably produced somewhere in the manufacturing world. That's all connected. And it's very connected right at Savannah River every day. So that cultural change that a manufacturing institute provides for education and workforce development is impacting things today. Thank you.
Now we're going to hear from Ashley and Nancy.
Good afternoon, everyone. So I'd love to stand up here and take a lot of time to tell you all about all the education and workforce development initiatives within the Rapid Manufacturing Institute. But I will only tell you about one for now, and that is our Rapid Intern Program. So as Vaughn mentioned, Rapid is, and also Nancy, Rapid is an institute that advances the deployment of process intensification and modular chemical processing. And as with many new advanced manufacturing techniques, they're either not part of the standard curriculum or slow to find themselves into the way of the standard curriculum within education today. And we found that that was the case with process intensification concepts. They were existing at a few universities throughout the country, but generally they're not part of the standard content curriculum in the universities and in the chemical engineering curriculum. So one of the first efforts that we undertook as an organization is to identify a way to start introducing students to these concepts. And so we did things like introduce webinars and introduce some technical content, but we want to do a one step further and really develop a program that would generate and develop the next leaders in process intensification and our technology. And so in talking with our industry partners and our members of our committee that serve in industry, we learned that the technical concepts weren't quite enough. We wanted to develop a program where these leaders coming out of it had both the baseline technical skills in process intensification, but also some baseline professional skills as well. So the Rapid Intern Program was born, and you may be asking yourself, how is this intern program different from any other intern program that might exist out there today? And Rapid is a consortium of members, 77 as currently, all over the United States, and we're a very distributed membership organization. And so we created a virtual intern program that's 10 weeks long, and overlays on the work that the students are all doing at their universities, at companies, and all the work that they're doing in these technology fields. So the students are nominated by professors, by managers, by someone like Dan at Dow, or someone like Hannah at Contact Membrane Systems, and they all become part of this group. And we do the program in spring and summer and fall. As a part of this program, they take between 18 to 20 hours of professional development content online, and that's about half of it's technical content, so things like fundamentals of process intensification, the role of process intensification in modular chemical processing, the design and economics of process intensification, and the other half is non-technical, and that we developed through the help of industry. So they identified areas that they wanted the graduates to know about. So things like applied project management, Excel spreadsheet problem solving, technical communication skills, professional etiquette. And so the interns all, over 10 weeks, complete the educational content. And also we develop this community virtually. So the interns all meet together on a weekly basis over a conference call, have a virtual discussion. And at the end of it all, they present virtually their work to a panel of Rapid members. So we've had participation from all of our industry partners, and they get firsthand experience talking with people that are doing this work in industry as well. So the individual Rapid interns benefit from the program because they not only receive this content, but they get opportunities to network with one another and industry members that are Rapid members. But Rapid and I believe the U.S. workforce benefits as a whole because at the end of the program, our member companies have a pool of talent to choose from that I don't believe would exist outside of this program. We've had, after 4 rotations of the program, we've had 40 graduates of the program from University of Pittsburgh, Praxair, Oregon State University, Shepherd Chemical Company, Stony Brook University, Missouri S&T University, Lubrizol, University of Arkansas, Intramicron, Savannah River, and Iowa State University. The program, we've also had one of our industry members tap us to create a custom program for all of their co-ops that go through their entire company's rotation. And I think, including 2 things that make this program successful for Rapid, and I think present significant potential for our organization as well as the other, as well as others, is that the virtual component means that we can reach students anywhere that they are. So we have broad reach within our membership base, so we can reach students that are in Oregon, Georgia, no matter where they are, as long as we have an internet connection, we can reach them. And the modular component of the content is important because what we can do then is we can, in ongoing discussions with our industry members, we can swap out content that they may need additional skills. So project management isn't important anymore, we need something else to replace it. So the modular component allows us to be flexible to industry needs as they evolve, which I think is important. And so to better understand, so one of the things we need to do is have a method to better understand industry needs. We have ongoing dialogue with our industry members, of course. But one method that we've been looking at, which Monty's going to talk a little bit more about, is using big data and identifying industry's ongoing needs in a skills-based learning way. So I'm going to hand it over to Monty to talk more about that big data and skills-based learning.
Thank you.
Good afternoon, it's a pleasure to be here. I wanted to talk about building on some of what Ashley just discussed and some things that we're pursuing at AICHE. I want to start with a little background about how the world is changing. So this little graphic up here is the transition we've undergone to the digital economy, where we used to have an agrarian education system back in the 1800s that was a linear K through 12 university and then into college and then off into life. And now everything's interconnected. So if you look around today, a 5-year-old and a 50-year-old can both be studying the same thing at the same time. There's not a day that goes by where you don't hear something absolutely remarkable from people that you would never, you wonder where do they learn these things. But this has profound implications for how we think and how we learn. So one of the things that Ashley mentioned, we've been working with a company named Burning Glass. It's a workforce analytics company. They have data on jobs postings. So in the US, there are about 30 million job postings open today. Of those, the top 2 jobs are truck drivers and nurses. About 20 million actually require a BS degree. 1 million require a PhD or a doctorate of some sort. And Burning Glass has an incredible taxonomy where you can do reports on jobs by company, by location, by skill level. There's 160,000 jobs that require machine learning as a skill. And so looking into this, we've been exploring what are the skills, what are the types of things the companies are looking for, and then how do we best design education, not just for today, but for life. Matt Siegelman is the CEO of Burning Glass, has a really wonderful YouTube video, and he says there's not a jobs market, there's a skills market. And when you think about the world that way, a skills market means when you graduate with a degree in a particular field, you want to acquire more skills as you go through life. So one of the concepts they've been developing is this idea of a hybrid degree. If you have a BS in chemical engineering, you might want to learn more about business. If you have a BA in psychology, you might want to learn some other things to advance in your career. So this whole idea of incremental skills addition is extremely important and part of what's happening in this emerging connected world. The other thing I like to talk about is the innovation supply chain. So I started my life working at GE Corporate Research. And I worked there in the days when we used to have a corporate research lab where we had great relationships with universities, we hired faculty, we had seminars, and then throughout the entire GE company, we had people across all the businesses. We actually started the corporate research center. And that linear model of university research to a company and eventually getting the products and services in a big company was an established research model that in the pre-digital connected world was pretty well established. Today, things move faster. Large companies struggle to innovate and afford these large investments in basic R&D. So a new model's emerged where you'll find every university now has an incubator, the idea of the lean startup model, how you take technology from the university and move it to a startup and eventually into the marketplace. In the bio world and software world, you'll find companies, if you go to Seattle, Boston, San Francisco, it's unbelievable. But this model hasn't yet been embraced and totally integrated in how we do education, how we learn going forward. One of the challenges that this is transition has been caused by this transition is there's funding for basic research. If you think about NSF, NIH, and some others, there's a lot of basic research funding that lives in universities. Companies also have development activities and research they fund, but it's usually a little bit more targeted, a little shorter term. And what has emerged over the last several decades is what's known as valley of death. It's actually getting an idea to the market. How do you actually traverse the valley of death when there's not a lot of funding? Companies don't spend as much in the middle anymore. Universities don't have that as a priority. So our belief is with AICHE and Rapid, this is an excellent opportunity to build on some of what Rapid has been doing to traverse this valley of death, to create connections. And so what we've been doing was we've been looking at how do we focus on the middle. We have company partners, university partners. How do we build a model of interaction, high-frequency exchange between these two worlds? And in addition to that, help students with this idea of what we call career discovery. It turns out, when I ask students, and most people, when you ask most anybody, what do you want to do in life, they don't know. And this isn't just when you're a student, this is what you get later in life. And the career path you will take is usually varies with who you meet and experiences you have. So we've been working with Burning Glass on this whole notion of how do we build a career planning process. And then down below in this cycle we have here, this builds directly on what Ashley talked about in the internship program. We're now discussing with companies what types of skills and capabilities do they look for. We want to then build micro-credentials and this idea of Classroom Plus to provide that education. experience, send students out on internships, not just as undergraduates, but also as graduate students, so they get experience in the workplace and then come back from the workplace with ideas to build innovation projects back at the university. Those projects, however, could be more than just research. They could be a startup, they could be an initiative, they could be lots of different activities that fit in today's world. We're also exploring how might we make this operate using grad students. So instead of having this be for students, make it about students, engage students and provide them the opportunity to have technical leadership and new experiences. And then the last thing I'll say is this isn't just about preparing students. The whole world of AI and big data. If you look at oil and gas, there's an incredible amount of data. There's data now emerging in materials development, pharmaceutical drug development. So this whole idea of machine learning and AI is in new development practices. We're looking at how do we use those tools and practices that are not being developed in universities, using that as a way to upskill companies so students go out and bring new skills and thinking to a company, and when they return, they come back with the types of problems and experiences that help temper the types of things they do within the university. So these are a number of initiatives we're pursuing. We've had several board discussions, and we look forward to building this out and connecting this to help not just accelerate innovation, but also prepare the next generation workforce. Thank you.
Thank you. So I'm Hannah Moran. I'm from Compact Membrane Systems, and you've heard a lot about the various things that RAP has been doing. So I'm going to talk very specifically about one example, which is our company and what we've been doing, and how the efforts that RAP has been doing has enabled us to move the company forward. So we're a very small company focused on one of the biggest problems in the chemical process industry today, separations. Separations are probably the largest energy user in chemical industry right now. They're also very capital intensive generally. So most of them are done through thermal separation methods or distillation. If you've ever seen, if you drive by a refinery, the largest tower is usually the distillation tower. So these are hundreds of millions of dollars of capital equipment, and they use a lot of energy to separate the compounds that we use on a daily basis. So what we're trying to do is develop membranes to do that in a much more energy light, capital light way in a modular method. So using membranes to separate these materials. Like I said, we're about 30 people, so very small. And in order for us to tackle this very large problem, there's a lot of pieces of the infrastructure that we need to move the problem forward. So RAPID fills a lot of those gaps for us. And you heard Monty talk about the valley of death. That's one of the areas that's the most difficult for small companies like ours. There are lots of ways in which we can develop new technology, whether it's through SBIR programs or working with universities or the initial development of the technology, but actually getting it from that inception phase to reality is one of the hardest things for us from both a capital standpoint, meaning cash for us to make that work happen, but also finding the partners and infrastructure. Because we're not making a widget, we're trying to integrate into the process industry, which is full of established large players who have a lot of installed capital on the ground that we're trying to integrate to it. And we can't do that by ourselves. So what RAPID has done for us is both give us the community to do that. So for our project, we're working with Dow to install a demonstration unit at one of their sites to demonstrate that our membranes can do the separation that we're working on. We're also working with universities, so we're partnering with the University of Minnesota to help us do some simulation and modeling around our membranes so that we can better scale up and optimize the systems. And it's enabled us to better prepare our workforce. So as you've heard, some of the workforce development projects here, we've hired 4 people in the last 2 months, which is a lot for a company of our size. And bringing those people quickly up to speed in the topics that we need is of critical importance to us. We need them to be effective the first day, if not the first week at least, that they arrive at our doors. And so programs like RAPID that give those people the skills and the mindset to be working in process intensification has been really critical for us. So across a number of dimensions, I think RAPID has enabled us to punch above our weight as a very small company in order to move a lot of these very difficult problems forward. So now I'll give it to Dan, who can talk about it from a large company perspective.
So I am Dan Rosinski. So the Technology Fellow program in Dow is modeled after Research Fellow. So it's really an operations fellow. So for manufacturing and engineering, the idea is the most pressing technology or technical problems that the company's facing in terms of manufacturing and engineering. We have a group of technology fellows that focus on that. And so it's where research and engineering and operations kind of meet, and we go after those problems. So for me, what that kind of turns into is I'm a chemical engineer, but my background has been working with systems for most of my time. So I concentrate on cybersecurity and things like digital manufacturing and bringing those systems together. So when we look at Rapid from a Dow perspective, we look at the technologies that we may not have found on our own. CMS is a small company. They've got some real innovations, but we as a large company do have a certain way of doing things. We have engineering practices, engineering disciplines that have been developed over decades. But what we're facing is a change in our competitive advantage, right? We can't just keep making stuff bigger with more, the ability to generate more capacity, more volume, kind of price per pound. We need to think about making things smarter and being more agile. And one of the things process intensification does for us is it allows us to start thinking about how would we get more agility. Instead of putting a great big chemical unit in the Gulf Coast of Texas, could we split that into multiple chemical units, right, that can come up and down and basically ramp up and down their capacity as the market demands. It's an incredible amount of power it would give us if we can get there, and companies like CMS that help us figure out how we would solve the technology problems to get there is really important. And for Dow, it's all about competitiveness. I spend a fair amount of time working with another Manufacturing USA Institute called MXD, Manufacturing Times Digital, based out of Chicago. It's the old DMDII, the Design Manufacturing, Digital Manufacturing Design Innovation Institute. And so for us, Manufacturing USA represents the ability for us to take steps outside of our comfort zone, steps outside of our engineering disciplines and the things that we've done the same way over and over again, and start looking at, okay, how do we now share some of the risks and bring in new ideas? And so, I know Bond talked about the culture change at Savannah River. I mean, we are undergoing right now in Dow, and most of the large chemical companies are, there's a huge culture change, right? From, basically just stamping out the same design over and over again to, okay, let's rethink about what that design needs to be to meet what we're seeing as a changing marketplace, right? A more global marketplace where the consumers have a lot to say, where sustainability, right, and being green is extremely important. It's not just a nice to have now, it's a must have if you're going to sell into marketplaces. So these institutes allow us to now bring and connect to partners that we would have a hard time connecting to otherwise. Our model has typically been, we would work with a single university or a single technology partner and work out a whole bunch of agreements and non-disclosures and IP protection and all this stuff. What Rapid and MXD allow us to do is to bring all that kind of administration into a central point and then plug in partners, right, on projects. And so it's incredibly freeing to us to suddenly now have a mechanism by which we can partner with more people, bring in more new ideas, and then move forward on some of these projects. I mentioned culture change. I actually talked a lot about this idea of internships and bringing people in and getting them started on their journey. We have another issue, which is we've got hundreds, if not thousands, of engineers and scientists out there who are bred in the Dow way, and so they need to think about what is now my role, what skills do I need to exist or to thrive in this new environment. So we have been working hard on apprenticeship programs, so taking young engineers and basically teaming them up with more senior engineers and bringing technology like process intensification into that, right? So the whole idea of the manufacturing workplace of the future is that we will be getting more out of every single person, right, that's working in it. Because in this country, we're not going to reduce our costs to the point where we can compete with countries that have a very low kind of wage scale, right? So what we have to do is we've got to be more productive. We've got to get more out of every single worker, whether it's an engineer or an operator. And so in our view, the way to do that is skills. We have to inject skills. And no matter what your education level is, right, the idea is if you have the skills to go ahead and make a difference for Dow, we're going to help you grow, right, into that role. And so, our theory, and we have doubled down on this idea of diversity and inclusion being gender and race and kind of the existence of physical or other handicaps, but also education level and, skill level that you've developed over the years of working with Dow. We don't see any of those as barriers anymore. We see them as opportunities to bring more people into these technologies. And so what we need, though, is help, right, from the university system and from the national labs and from the government to help us kind of bring that program together, because Dow on its own is not able to do this, right? I think it was Ignacy talked about this idea of being a convener, so bringing people together to solve kind of common challenges. And clearly for us, that's a huge advantage of working with both Rapid and the other Manufacturing USA institutes. So, I would just leave you with the thought that we're a big company. We have a fair amount of resources, right? There's a lot of things we can spend our attention on. What we're finding is one of the most valuable ways to invest is through these kinds of institutes. And so we are kind of all in. We've got a lot of investment, a lot of people like me and others involved, and we're pretty excited about what the future holds. Thank you.
Thank you. So we're going to hear a little bit more from Monty to close the speaker part of the event, and then we hope to have a lot of questions.
So I'll just share a few concluding thoughts here. The world of today, we need to operate and think differently. So we need to not just consider what we do, but how we do it. The what for Rapid is this notion of process intensification. It's transformational new technology and design for problems to extend the existing industries, very capital-intensive industries. The how, though, is the approach. Partnerships, working together, collaborations, no longer one-to-one, but communities of practice, both from the market and also from the innovation side. To do this, we need to have new partnerships. We need to have the ability to create these models, but not just for education or research and innovation. We need to think about these as being concurrent. Learning on the job, learning by practice, experiential-based learning. So education and innovation become married together through these types of initiatives. Rapid has been successful because it's been a really wonderful public-private partnership that has proven a number of different concepts out in practice. And at AICH, we've been exploring how might we build on this, and we extend this education and learning model and also innovation to create future public-private partnerships to accelerate innovation to market and also prepare the workforce of the future. So with that, we'd like to thank you very much for attending this afternoon. We'd like to take any questions or any thoughts that you might like to share. Thank you.
We're open to questions or comments from all of you in the audience. Mike?
So we heard Dan talk a little bit about what's going on with like MXD and Rapid. I guess this question is so how is Rapid leveraging with the other USA institutes with regard to education?
Oh, that's a great question. We have, we convene as all the education workforce development directors convene fairly regularly with each other. And we participated recently with several of the other institutes on a project call. The results of that are to be determined, but we find that education workforce development is such a common theme throughout all of the advanced manufacturing technologies that it's an area where it's natural for the Manufacturing USA institutes to collaborate on efforts that benefit the entire workforce. So there's a number of areas to work with them on, and we're finding that it's a very natural fit. And I think you'll be seeing more out of Rapid shortly along those lines that I can't talk about yet.
Yeah, I would add that that's one of the areas that we're working on, we're supposed to work on, but we would appreciate the ability of having some specific tools and some specific programs to enhance that collaboration between the different institutes, especially when the institutes, as you might know, Manufacturing USA has institutes depending both from Commerce, Department of Defense, Department of Energy, and working across the different departments, it's relatively tricky, especially when there's a lot of good intention, there's a lot of trying, but there's no specific programs covering across. So, that would be a very, very beneficial thing to have.
Yes, I just on the same subject of workforce, and what I've heard so far is very impressive in terms of what you're doing. My issue is scale. Do you think you have enough funding to reach out to the overall economy of the country to make the kind of impact that you can make? Because as you know, if you move quickly, and whatever you're teaching today becomes obsolete maybe in another year or two. So my question is, there were discussions prior to this meeting about whether or not there should be another Manufacturing USA Institute that focuses on workforce and takes all of these nice ideas that you have and just have it as a focus and fund it appropriately so that the U.S. economy as a whole will benefit from the advances that you make. Do you have any comments on that?
Well, from Rapid's perspective, I can see where, from our technology perspective, we've approached workforce development in a different way than another institute, just because they have a different technology and that technology has a different set of needs. So I can see where a benefit would be where if you bring it all under one organization, you could address some of those more systemic challenges. But I don't know if I'm answering your question.
Actually, I'll tell you
Yeah.
what so from my perspective, you know, while I'm in a national lab, manufacturing is our focus. You need that culture change to be driven by both education and innovation simultaneously. You heard from both Monty and Dow that, you know, having that paradigm where innovators and educators are all working sort of in one direction, it is very, you know, beneficial. I gave you several examples where our culture changed and then was further amped up by Rapid. So I think your model is pretty good in the Manufacturing USA. In the DOE institutes, as you well know, you know, it's 5 years now. In the DOD, there may be different models, or in the Commerce, different models. So from my perspective, getting that culture change to continue that for national defense reasons is probably going to go forward for us because we keep finding good examples as to, you know, we're over that valley of death. But there are obviously other aspects of it. You know, there are several programs now, which I can't speak on, that are just in the pipeline that are getting going. Whether they get through the valley of death in the national defense market or in Dow's case will depend on whether or not there's a focus within, say, the chemical process industry of this way. And I don't know if Dow would like to comment further on.
Yeah, so I mentioned, you know, that we're in MXD, we're in Rapid, we're in a couple of other, the Manufacturing USA, and our overriding message back to Rapid and to MXD and all the organizations is we can't afford to duplicate efforts, right? So if there's some good workforce development learnings that Rapid's done, I want to bring that without any barriers over to MXD or to work. I mean, if it's things that can be reused, because from Dow's perspective, right, it's all part of the same idea, which is we want to advance our competitiveness, okay? And so your comment about workforce development, it is a common element. Now, there are some specific things about process intensification versus digital thread, which is EMBI, you know, that need to be specific, but there, I believe, and we're already talking with the various institutes about, there are common areas that we should all leverage. And to the degree, to Ignacio's point, we could get the departments to agree not to put up barriers between that sharing, you know, and to the degree that people in this room can help with that, that would be great from Dow's perspective. Because we would get more from it, and the country would get more from the investment.
Yeah, we also enhance the ability to come back to the Hill and say, hey, look, this is a national priority.
Yeah.
We need to get this out as quickly as possible.
Yes.
You know, what can
Yep.
we do to help?
If I might add, so I'm actually the CEO of Rapid, so I'm intimately familiar with what the folks are talking about vis-a-vis education and workforce development and how we work across agencies. I would suggest the model of perhaps organizing at a national footprint level education and workforce development would be better served by, to Ignacio's point, having the agencies find a way to create perhaps a pool of funding that could then transcend all the different, or be spread across all of the different existing manufacturing institutes to share best practices, to, for example, bring the Flex Factor K-12 STEM education program that NextFlex has to different institutes, or to bring our internship program to other institutes that might benefit from it. And so we are each finding unique and novel ways to develop the workforce development efforts that our particular industries need. Some of that's portable across different industries, and we should do that to the extent possible. I don't think, I mean, just from my perspective, in terms of the best use of federal funds, it would be more efficient to put those dollars to work in the programs that are already generating real results with the workforce, rather than creating yet another institute to do, you know, to have to come up and build infrastructure and learn all the things that we've had to learn along the way. Does that make sense?
Oh, yeah. I mean, I think using the word institute might not be the best word, but the idea is to recognize that need and to have a focus from the appropriators to say, hey, look,
Absolutely.
I mean, when we proposed the institutes, we didn't think very deeply about how to do the workforce part of it. But now that all these great ideas are coming out, you know, we may need more resources to do that. So whether we call it a separate institute or we call it a pooling of funding,
Or a different method,
you know,
right?
it doesn't matter. We can all get together and agree on that language, and then use that language to organize ourselves in coming back to the hill and say, hey, look, you know, we need this arm of the whole process to make a difference.
And you'd actually asked another question about, I think the initial question was whether there was sufficient funding. So the way, to Bond's point earlier, the way the Department of Energy funded institutes work, we have a 5-year cooperative agreement. Beyond that time frame, we're charged with finding our own model of financial sustainability. And frankly, education and workforce development is a big part of that for us. Finding the right mechanisms, finding the additional funding and so forth to ensure that we can train the workforce for the future is critical for us.
Question?
Yeah, I'm from the NIST Manufacturing Extension Partnership. You know, we had conversations with Bill and Vaughn, and we work a lot with small and medium, meaning less than 50 employees. And I guess this is a question for Dow more than anything. When you look at our services, you know, 30% of our services is for metal fabrication. You know, your shops are making the heat exchanger, the pipe and all that. I'm a chemist, so I know when you start getting into all this mass transfer and heat transfer, you're talking a whole redesign of some of this equipment. And that may require some skill level with regard to new welding techniques and things like that. How much Dow likes to go down into that tier 3, 4? Because that may become actually very critical at the end, because if you cannot make those particular equipment with the new designs, so what's the philosophy of Dow? I know Rapid is interested because we talk to them about it, but what about Dow? Where do you draw the line in your tier, in your supply chain, where you say, you know, that's somebody else's business?
Yeah, so I mean, it's a very similar discussion in MXD, where a lot of the small and medium manufacturers are part of the supply chain for the defense industry, right? So, and we have our supply chain, right? We've got our providers, and they have skills, and they're able to build things that we need, right, to then populate our plants. And so your point is exactly right. So we don't draw any lines, but the major challenge we have right now is figuring out how do we turn the corner in Dow towards using the new technology in the new designs. Now, the question is, if we turn that corner and suddenly we're starting to put out designs and asking our suppliers, hey, can you build it this way? You're right, you're going to get a blank stare, right? If they have never heard of, gee, why would you build a column that small, right? You guys have always asked for big ones, right? So it's a really good point. It's something we are preparing and wrestling with a little bit. We believe it's important. We don't have an answer yet, but we're hoping Rapid and MXD and others with strong SMM, small and medium manufacturer programs will help us, right, get that message out. And, you know, if you have a manufacturing extension partnership, then that helps too.
So that question came up 4 or 5 years ago. We visited Europe looking at this subject, and DSM, the chemical company, wanted to make a micro heat exchanger and deploy it. They actually ultimately did that, but what they did was through European funding develop a consortium around specific needs around manufacturing of that type. They knew that if they created bought 5 of these heat exchangers or microreactors from that company, the company would go under and they would never be able to buy them again. So they had to help those small, medium-sized people create a market by having enough tier 1 suppliers involved in that consortium. That has not completely translated into the manufacturing USA culture. I remember writing that into the proposal. It's just a matter of how much energy and resources you have to apply to it. But that is a problem with innovation. You get down to a point where you don't know how to make the idea that you've come up with cost effective. And you have to develop a consortium around that so you can create a market. I mean, the prime example of that is the nuclear reactor, right? We can't cost effectively make a lot of the parts that go into those things, hence that's why 2 of them are not being built now, right?
Especially, it seems like one of the greatest resources Rapid's offering is a larger access to a larger pool of student resources, right? So what are the primary barriers to educational institutions like engaging with you, getting the students into your program? And are you providing, or are there any existing best practices for students to kind of adhere, programs to adhere to better engage with your programs and kind of move up?
Yeah, so I think one of the significant advantages that Rapid had just starting out that some of the other institutions didn't was a partnership. It's developed underneath the American Institute of Chemical Engineers, so they already had a complete infrastructure for educational programs, already a student population that was already engaged with. They had 30, is it, Darlene can fact check me, 30,000 some student members. So we were at a significant advantage where we had access to a number of students, and we also, we have great faculty engaged within Rapid. We've definitely learned from AICHE. They have CCPS is the Center for Chemical Process Safety. They develop SASH modules that are e-learning courses that faculty assign students within their classrooms, and so we took a page from their playbook and developed e-learning modules in very similar fashion. So we were at a significant advantage there, but I do think, so I think some of the barriers were a little bit harder to get over for some of the other institutions. I think we had it pretty good with AICHE.
With your virtual, so you spoke a lot about virtual education engagement with your internships. What are the trade-offs between a virtual fellowship or internship versus like an in-person?
Sure. So an in-person is always going to be more engaging. You can get some instant feedback right there. So we've tried to overcome some of those downsides of virtual education with the Rapid Intern Program. So as I mentioned, we have weekly meetings with all the interns, and that's where we get them all together and talk about the learnings that they have going on. And so while it's not the same as being face-to-face with them in a meeting, we do get to get some of that instant feedback and provide some context for a lot of the things that they're learning, and they get to talk to one another about that. So while it's not exactly the same as a face-to-face program, it's definitely way better than just here, go take these e-learning modules and check them off a box. We definitely foster that engagement and that participation, and we've seen that it be really impactful. And we get the interns themselves. One of the things that they really respond to about Rapid is the ability for them to be involved in not only such a groundbreaking area of chemical engineering, but they really connect with the sustainability potential within Rapid. And so it's really neat to hear them talk about where they can see it going, where they can see it impacting their careers. And so, well, it's not as great as being face to face. It's also not as expensive. There's no travel involved, so it's really that sweet spot.
So I will add, and I don't know if Hannah kind of has a feed from a small manufacturer point of view. The idea that the digital world and the physical world have to coexist, right? We've lived in the physical world for decades. The digital world is now moving very rapidly and has been moving into the physical world of manufacturing. And so what we don't want to do ever is disconnect the two, right? Where everything's a simulation and people start to forget that there's actual equipment underneath, right? And so that's a challenge for us. And Rapid and other institutes can help us kind of bridge that gap from one direction. We have to be very active. And in fact, we're working with MXD and hopefully with Rapid at how do we create the hands-on experience, right? You know, not at a Dow plant necessarily, but are there some neutral areas where these institutes can stand up process test beds or equipment test beds, or, you know, so that we can get the hands-on manufacturing operations experience along with, right, the virtual experience, which is, you know, we're leveraging, so.
And I should also add that the Rapid Intern Program is one feather in our program portfolio. So we are, through our project call, we have 4 face-to-face hands-on courses that are in development that are really in-depth content, technical. So it is just one other element of the portfolio that we're working on. I just didn't mention that.
Yeah, I was going to echo some of what Dan said. So even though we have not hosted a rapid intern, we have, through the course of our project, we were working with the University of Minnesota and had a grad student who was the main person working from Minnesota along with his professor. And so while most of it was virtual, he was simulating our membranes in a computer program, and we didn't see him very much. He was in Minnesota, we're in Delaware. There was a lot of learning for him of, he had been used to working on simulations that were kind of abstract, and we were saying, no, like, this really has to work for us. This has to be very tied to what we're trying to achieve. It's very tied to the end goals. We're going to be making these units. We need to know what we're going to put inside them. And so I think for him, it was a big learning that it was much more tied to reality than anything he'd done in grad school to that point. So even though it's virtual, I think having that cross-pollination between industry and academia has been very fruitful.
In most of the rapid program, Savannah River hosts a rapid intern. They get direct, you know, manufacturing experience, just like they would at Dow, or, you know, within a research process support laboratory that is day-to-day trying to solve a problem for the manufacturer. So the virtual part of it we didn't have within our program at Savannah River, and Rapid offered us that. So they get national exposure to other interns at other companies, and that we could not replicate. I mean, Savannah River is about 10,000 people, right? So we're not the 100,000 or 200,000 of Dow is, where maybe they could pull together, hey, all these different experiences. So I want them to have an experience from a chemical company, learn a technology, maybe bring that back into the weapons complex so that I can make America safe.
One of the things we're doing now, we're getting ready to schedule our final presentations for the fall program, and so I have the students look at all of our rapid members and say, who do you want on your panel? You tell me what company you want theirs if you want to get a job with someday, and I'll do my best to get a member from that company on this panel, and they get to start thinking about where they want to work someday and get exposure to that organization.
We're on the same line.
Okay. I'm Bob Hershey, I'm a consultant. What is being done to get pool funding among the various participants and get agreement on what people want to do jointly? And you have meetings over the internet and go through some of these things?
Within the rapid, for example. Okay, so we have, you know, most of the work we do on the project side is both on the R&D, on the occasional. We have, excuse me, internal mechanisms in which when we open a call for proposals, whether it be R&D or educational, they get submitted. We have internal committees made out of the members in some level of proportion to their current participation or their interest that get reviewed. They get ranked, and then they come to us in the rapid staff and technical staff if it's R&D, and more in the educational, which is, educational is kind of technical and non so technical, but still technical. And then we decide on which, you know, it's not straight up ranking, because sometimes very well ranked proposals might be very similar in terms of topics, and you want to have coverage, not just go for the top 3. And we make a decision. So we, because of the membership, we obviously have to operate as a membership organization, but we want to do it in a transparent way to our members and to our sponsors.
So, if you had more funding, whether private or federal, what would you do more of?
Obviously, we do more of what we do, and we do other things too, right? So, on the educational side, we obviously would do more innovation, and we would look at So the way we have decided a lot of R&D work is by doing a big road mapping exercise, looking at gaps, and looking at having coverage of those gaps. When you do that, you discover other gaps or more detail or a little farther away, and you try to cover those. So in a way, this road mapping and gap coverage is kind of an iterative process. It's not like you do it once and you do it, you go back and forth and back and forth. On the educational side, I think, and I would say because of us being American Institute of Chemical Engineers, the first look has been chemical engineers and chemical engineering education. Is looking beyond that, looking at technical training for operator training, looking at managerial skills for engineers and non-engineers, so expanding the base, going to K-12 even. So it's the intention, but obviously you start where you're more comfortable and you think you can make a bigger impact right away.
I'd also like to say that I'd like to see the intersection of both what I call the physical and the digital and the cyber security. Nobody's going to own their server in the future, right? We still do because the manufacturing site, we're gradually moving away. It's amazing enough the classified side's moving faster to the cloud than the unclassified. But all our manufacturing, generally, lots of it's unclassified. The intersection of the manufacturing institutes and more joint projects in that direction could be much more impactful. Because no matter what physical device I put in there, I still got to deal with the digital when I hook it up. And then I've got to ask myself, can I connect everybody with one of these, including the president? And what cybersecurity risk does that present? Right? And I want everybody connected with one of these because I want to know if my unit's offline, at night.
I'll amend his statement. He wants everybody who should be connected. Thanks, cyber guy.
Everybody in my company.
Yeah, this is a question for you. As a small company and dealing with Dow, I imagine the conversation on intellectual property came up. How do you,
Yeah.
Yeah, talked about it.
Yeah, so of course it has come up, and I would say it's been, for a small company, we live and die by our IP because that's sort of what defines our value in many ways, is that IP. And so I think in some ways it was simpler than I thought it was going to be with Dow, in that Dow from the outset said, we're not interested in being a membrane manufacturing company in this area. They have other membrane efforts, but in this particular area for gas separation membranes, they don't see themselves going into this business at this time or in the foreseeable future. And so they were very happy to say that any IP developed on the membranes was ours. Any IP developed on the process was theirs, which for our perspective, again, was fine. We're not developing new processes. We see that as their purview. If it's somehow connected to a process that they're developing, we're not going to have the know-how to put any IP around that anyway, but if it's the membranes, it's ours. I would say the rapid process was quite simple in that they didn't add any other sort of caveats on top of that. There wasn't then a whole layer of, okay, Dow and us have to figure that out, and now we also have to figure that within the rapid framework. The rapid framework was very simple to have that discussion, and so it was shockingly quick with Dow. We've had far more complicated discussions than that particular one where we were able to sort it out pretty quickly.
Nice. Thank you.
Yeah, I would add just real quickly that the IP conversation is an important one. We decided early on to be even more than Rapid doesn't own any IP on the R&D side. We own some on the educational just because it's the value, right? But for some projects, what we have learned is to encourage people to have that IP conversation as early as possible. Because people can get into some of these projects with very different ideas and thinking that their idea is the logical one. And then when they sit at the table, it takes a while. And sometimes you have these projects that are ready to go, but they cannot get moving because there is IP people on both sides, large, medium, national labs, universities that have very different ideas. So talk about it early as possible is what we've learned from it.
I put a lot of talk, I'm sorry, I'm Kim Phil with Stormstone Communications. I hear a lot of talk about workforce development, but as I'm sitting here, I'm thinking about how does Rapid, or how do all these partnerships respond to real situational development. For instance, every year I'm engaged with the high school here in DC. They have a Transform Academy, and they have Industry Day, and they invite people from industries to engage with the students because they have labs and simulators where the students are working on actual projects to solve some solutions. And I was thinking one of the things that they were working on was water purity, because basic America's water systems are toxic. It's not just Flint, but there are other, even here in DC, there are high lead levels in the water here. So there are students in high school that are concerned about those issues, that are working on those real situational crisis issues. And they've come up with filtration systems that are having an impact and increasing the purity of the water. So how do you engage with those kind of, I guess, work that students are doing, even at the high school level, to try to bring those real situations to research and development, and perhaps if they work and have an impact, to market, and they could be a solution?
That's a great question. So one of the things that we are, so building off of the successes that AICHE has had with the student community, every year they do a student design problem for college students. So I haven't answered your question about high school, but I'll start with college. So, and this year Rapid developed the student design problem for the chemical engineering, and they typically complete that problem in their senior year of college, and this year's problem is on distributed ammonia synthesis. And so at this college level, students are starting to think about these problems that modular process intensification can solve, and are starting to put together real solutions for it. In addition to that, we're looking to expand into a student competition, and we've already convened a working group to develop a proposal for it. So there's definitely ideas on the table for that. And we're also working with some of the other institutes on a K-12 program. So there's nothing to demonstrate today, but we have it in the works and hope to have something to demonstrate a year from now.
Please. There's also a big opportunity to extend this concept of knowledge network much more broadly. So at Penn State, where I am, Penn College actually does a lot in terms of training workforce development. And it goes back into high school. So we no longer have to think about K through 12 university workplaces. It's all connected. So if you're looking at water treatment, having some kind of content or practices available that you can find no matter where you are can be extremely valuable. All you have to do is look at what young people do today. They go onto YouTube. If you go to YouTube, you can find just about anything you want. How do we get to that same sort of approach where how to do things is much more readily available? We tend to teach classes in terms of subjects like I'm going to teach you thermodynamics. I don't want to know that. I want to know how do I balance a reformer? How do I tune a control loop? How do I install a drop ceiling in my house? How do I design a water purification system? Inventory. How do I do something in addition to the core and underlying knowledge? Both axes need to be part of this global knowledge network.
So one of the most impactful programs I've ever seen that addresses your question is Bridgestone Firestone. On its own, went out and recruit people in a high school to go into a tech program to learn how to maintain robots, right? They have all kinds of robotic, a lot of their factories don't have anybody in it. And the way that tech program was designed is you could do 2 years there, and then if you wanted to go on and do 2 more years, you get a 4-year degree. So it's very, rather than a typical junior college approach where you're not taking really a lot of hard skills, sort of a marriage of that. As far as I know, there's a little bit of NSF funding where they ask for K through 12 development, but a program that takes a manufacturer, an innovator, and a high school together and sort of develops that supply chain of resources from high school, bridging through tech school, and then if they want to go on and on. We tend to look at, there's tech college funding, or there's 4-year funding, or there's PhD level programs. An integrated program across that would address your particular question, I think.
Maybe extrapolating from that, a bunch of you mentioned diversity in the workforce. That can take a variety of forms, but be as active or as passive as you want on that spectrum. Could you guys comment on some active programs you have to improve the diversity of the workforce pipeline?
Yeah, I'll start. I mean, at Dow, I mean, we actually, especially in particularly focused in operations, which is where I live. It's a corporate-wide program, but we basically took, 300 operations leaders from across the company in December, right before the holidays of last year, and took them to what we called an operation diversity. And basically, the idea was our senior VP of manufacturing, we had a bunch of guest speakers and we had a program, and now we've got this kind of cultural imperative that we will get more diverse, that we will find, there's a gender gap typically in operations, so find more female candidates, give them the ability to grow, right? Don't let them see any barriers to their growth in those technical areas. And also reach out to other, populations that aren't represented very well. So in the midst of being competitive, we believe that diversity is a competitive advantage as well. Because what we believe, and what Dow believes all the way up to our CEO, is that there are ideas, there's innovations, there's creativity, there's power from groups that have not been represented. And Dow, being kind of an old style company, has left ourselves out of that. So, I can point you to a bunch of, kind of external facing things that Dow's doing. But internally, I can tell you, we take it very seriously. And in fact, we're investing quite a bit of attention, money, and time with the idea that diversity and inclusion equals competitiveness, right? So that's sort of the simple equation for us.
I have a little bit easier because different parts of DOE help us with programs from, everywhere from historically black colleges to minority, underrepresented organizations. So I'm lucky I have a whole pipeline of funding that allows us to do collaborative research that then gives us a pipeline of people that, could come in and be hired. And in terms of the existing workforce, I have to say over my 35 years career, it's all about performance for us, right? How well they're doing in the research program, how well they're managing people. And so, at least in my perspective, it's always been, you look at the person's performance, you're not looking at what group they're coming from. That said, we're always trying to, just like Dow, it's hard to get folks to go into operations that tend to be non-male for whatever reason. That's been the tradition, so we tend to emphasize that a little bit more and try to recruit people and say, yes, you can, manage a bunch of operators that are all male. It's, they're not, so, they might be, usually what happens is it's a younger lady, and a lot of these guys have daughters that are that age, and so they're very open to that kind of thing. But the person that's coming into that job doesn't realize that, right? So some of that is just training of the candidates coming in and trying to convince them that, yes, they can do it.
I think from the rapid intern perspective, historically, for the 40 graduates that we had, about 60% are male and 40% are female, which I think is a little bit better than the trend. Obviously, we're pulling from a population of chemical engineering, so we really do benefit from the ongoing efforts that AICHE is doing in diversity and inclusion, both from pushing, women in the workforce, but also the LGBTQ initiative has made huge strides recently. So from a diversity perspective, we're definitely proud to be part of AICHE, and I think that their efforts have really been fantastic lately.
And I also wanted to give a point to the MEP program, which has helped us a lot to connect with a lot of smaller and medium-sized companies, oftentimes women minority-owned companies. So a lot of the corporate diversity has come from that connection. So very, very important for us.
I think we're over time, so
Okay.
why don't we thank Rapid Institute and the panel members.
Mike, I wanted to put in a plug in for the Journal of Advanced Manufacturing.
That's what I was going to do, is do a selfless plug.